Okay, so here it tells us use reference points and symmetry to complete the table of values for each function, then graph the function on the corner plane. State whether the function is an odd, even, or a neither. The first thing I see is that the parent function is c of x equals x cubed. And then it's telling me that h of x, they're doing some kind of transformation to it, so the only difference between this problem here is this -3. Class, that -3, is that on the inside or outside? It's on the outside. What letter is that? A, C, or D? That's our A value. A value is equal to -3. Does that affect the x or the y? It affects the y. So if you're kind of lost on this next set of 8 questions here, you can write down this formula. 1 divided by b, x minus c, comma, a, y minus d. The a value affects the y's. What math operation is there, class? Multiplication. So what we're going to do is we're going to take the y values and multiply them by -3. Take this y value, multiply it by -3. So 0 times -3 is what, class? 0. 1 times -3 is -3. 8 times -3 is -24. Notice here how the x values are not touched. They're the same. Well, how do you get, I only have 3 points, how do you get the 4th and 5th points? Well, if you graph this, 0, 0, graph it with you. I already know the answers there, but I want to teach you how to get there. 1, -3. That means going right 1 and then down to -3. And then 2, -24. So right 2, down -24. And then basically what we're doing is we're kind of doing the, if it's at the origin, everyone say origin? Meaning it hasn't been shifted to the left, right, up, or down, then I'm kind of staying here at the origin, and I can do exactly the same what we did here. Instead of going right 1, down -3, I can now go left 1, up 3. Instead of going right 2, down 24, I can go left 2, up 24. And then this is my graph. Okay? So use reference points. So our reference points are these 3 plus the other 2 I just found. And symmetry to complete the table of values. So we use the table of values just using your A, B, C's, and D's. And then it says, do you guys notice what I'm doing? Every kind of verb, I'm kind of completing a check. So it says complete the table of values. So I did that. Then graph it. We graphed it. Then state whether the function is odd, even, or neither. Well, I can do a couple of things to figure out if it's odd, even, or neither. If I look at my graph, let's highlight it in a color so you can see that very clearly. Class, is that symmetrical about the y-axis? Can I fold it? No. So that's not evenly, right? That's not symmetrical about the y-axis, okay? Is it symmetrical about the origin? Yes. Remember, symmetrical about the origin means a couple of ways of describing it. In orange, you're going from corner to corner. Another way of describing it is it's rotated 180 degrees. So if I take my pen here, and you can kind of twist it around, 1 and then 2. So this answer is odd. Do you see that? You can also have done that algebraically by substituting in -x for every x. And that's how you do question number 1.